back to the deep dive. This week, we're really diving into something huge, preparing for the AI future in automotive design.
Yeah, it's a big topic, definitely evolving fast.
And our insights today, they're coming straight from the experts over at Bluewater Auto Restoration. This is based on their Week 24 podcast for 2025.
That's right, they dedicated a whole session to it. And for folks listening, Bluewater Auto Restoration, they drop new discussions every Saturday morning. Always good stuff.
Absolutely. So their recent talk on AI and auto design, it really struck us as something we needed to unpack further. And for you listening, maybe you're trying to get a handle on these big shifts, quickly, thoroughly, without getting totally lost in the tech jargon.
Yeah, that's the goal here.
Our mission is basically to break down these core AI concepts and, well, explore how they might really change automotive design, give you some clarity, some practical understanding.
Think of it as your guide to what's happening with AI and how it could reshape, how cars are actually dreamed up and designed. We're leaning heavily on what the Bluewater Restoration folks shared, focusing on the real-world side of things.
Okay, so first things first. We need to get the fundamentals down. A key idea they talked about was AI being intelligent, not smart. What's the difference there?
That's a really useful distinction, actually. Helps move past the sci-fi stuff. It basically means AI runs on math, on data analysis.
Right.
It's not conscious, not thinking like a human.
Right.
They used a great analogy, baking a cake.
Oh, yeah, the baking analogy. Ingredients, recipe. Walk us through that again. Helps make it stick.
Sure. So imagine your data, text, images, whatever, that's your ingredients. They get turned into numbers, matrices. The recipe is this complex math thing, a weight matrix, saying how to combine everything.
Right.
Mixing is the calculation, the matrix multiplication, and the final cake. That's the AI's output, an image, a prediction, code.
And training the AI is like adjusting the recipe until the cake's right.
Exactly. You tweak that weight matrix based on feedback, more data. It learns, adjusts. It's this constant refinement cycle.
It feels like AI just exploded onto the scene, but it's really been building for decades, hasn't it?
Oh, absolutely. The core ideas go way back, like the 1950s.
Yeah.
But the big leaps, well, 2012 was huge with deep learning breakthroughs, convolutional neural networks.
Yeah.
Then 2017, another massive step. This paper on transformer architectures, that's the bedrock for so much of what we're seeing now, these mega models.
And transformers gave us things like attention, context windows, embeddings. Let's break those down. Attention, is that basically AI's focus?
You got it. Attention lets the AI figure out what's important in all the data it's looking at, like a really smart highlighter.
Okay.
So if it's reading a design brief, it knows to focus on, say, aerodynamics or safety requirements. Those become central.
And context windows, that's about how much info it can chew on at once.
Spot on. And they're getting bigger. That's why AI tools are getting so much better. They can handle longer text, more complex code, generate more consistent video, because they see the bigger picture, more data in one go.
So the ability to use more data effectively at the same time is the key improvement there.
Exactly. It's not just having the data. It's processing more of it simultaneously.
And embeddings, that's about understanding relationships.
Yeah, embeddings turn relationships, semantic meanings, into just sort of geometric information, points in space. It lets the AI quickly see connections, like it knows a sleek coupe is closer design-wise to a sporty sedan than a big SUV, just based on how those concepts cluster together geometrically.
Okay, going back to intelligent, not smart, it seems crucial to remember AI's processing power versus human understanding.
Totally. AI has the raw intelligence, the data crunching power, but it lacks human intuition, common sense, real-world smarts.
Right.
It doesn't understand values, preferences, the why behind a design choice, not like we do.
So it's an amazing tool, but it needs our human smartness to guide it.
Absolutely. Without that human context, that framework, AI could churn out stuff that's technically correct, but totally useless, or misses the point completely.
Which brings us to that whole hierarchy of AI terms the Bluewater Restoration podcast covered. It can definitely feel like alphabet soup.
It really can. So, okay, quick breakdown. Artificial intelligence, that's the big umbrella. Everything trying to make machines intelligent.
Got it.
Machine learning is under that systems learning from data. Deep learning uses these layered neural networks, a subset of ML.
Okay.
Generative AI is the type that creates text, images, code from prompts.
Right, the creative part.
Then foundation models are a type of generative AI, often built on that transformer architecture, trained on massive data sets. And yeah, all of this is becoming super relevant to product design.
And these foundation models get better, more useful as they get more specialized.
Exactly. You start with general models trained on like the whole internet, Then you get models that understand physics, spatial stuff. Then industry-specific ones. They know about manufacturing, production, automotive details.
Ah,
And right at the top, custom models. Trained by users on their own specific data, their workflows. Very tailored.
that makes a lot of sense, that progression. Now, Bluewater Restoration also stressed responsible AI development.
Yeah, super important. Developing this stuff ethically, securely. Things like AI transparency cards are popping up.
Transparency cards.
Yeah, they tell you how a model was built, what data it used, how it works.
Yeah.
Helps people make informed choices about using these tools.
All right, fundamentals covered. Let's shift now to how this stuff is actually starting to hit automotive design. Bluewater Restoration talked about exploring the edges of the map, how AI might tackle tough design challenges. First up, capturing design context.
Yeah, this is where it gets really cool. They talked about three things coming together: capturing spatial context, retrieving knowledge context, and automation through function calling.
Spatial context, that's the neural radiance fields, Gaussian splatting stuff.
Correct. These let designers grab super detailed digital copies of real-world inspiration. Not just shape, but color, light, materials. Really high fidelity.
So way beyond just a photo, like a 3D snapshot.
Exactly. A much richer reference. Then for knowledge context, they mentioned retrieval augmented generation, RA.
Oh,
So RA lets you basically chat with your company's entire data vault docs, spreadsheets, images, video using normal language.
Wow.
The system pulls relevant info to help the AI answer your questions. Imagine asking about a design decision from 10 years ago and getting the reports, the reasoning, instantly.
That could totally change research, understanding why things are done. Game changer.
Could be. And function calling ties into this.
How so?
Function calling lets the AI actually do things with other software. It can go fetch specific data, run a calculation, trigger a process based on what it understands.
So it's not just giving info, it's taking action.
Exactly. It becomes an active participant.
And bringing those three together, the spatial capture, the knowledge retrieval, the function calling, that's the potential shift.
Precisely. It could fundamentally change how design teams manage references, maybe automate tracking design intent, speed up that really early conceptual phase.
Can you give an example, like in a car design workflow?
Sure. Maybe a designer uses RAG to ask about past aerodynamic tests for a certain shape. The AI finds the reports. Then, using function calling, it automatically pulls up the 3D spatial scan, maybe done with Gaussian splatting, of a related older model.
Okay, I see.
Or you capture a cool lighting scene outdoors, the AI analyzes it, then automatically triggers renderings of your new concept in that exact lighting. Lots of possibilities.
Moving to the next challenge, generating concepts quickly. AI seems to be flying ahead in media generation.
Oh yeah, the realism is getting crazy good fast. Bluewater restoration, called Visual Media Liquid, meaning it's super flexible, easy to create and tweak now.
And 3D model generation is right there with it.
Yep. AI can spit out detailed 3D models, textures and all, in seconds, not hours or days. This means designers can explore way more variations, try more radical ideas, and pop them straight into virtual environments. It's an area that's just exploded recently.
So more options, faster iteration.
Exponentially more options, potentially uncovering designs you wouldn't have found otherwise.
And video generation. Visualizing concepts in motion.
Definitely. Bringing static designs to life in realistic settings. Stakeholders can experience it dynamically without needing a physical model right away. And the quality, the consistency, it's getting much better.
They also mention AI generating textures. That's huge for the look and feel and manufacturability.
Yeah, AI tools can now simulate materials, car paint, interior fabrics with amazing realism. Helps designers connect the look with how it'll actually be made much earlier on. Avoids costly changes later.
Okay, generating is one thing, but control is key. They talked about motion prompting for videos.
Yeah, that's exciting. Gives you much finer control over movement in AI-generated videos. You can set broad paths or get really specific using your cursor to guide motion within the frame.
So you can actually direct the AI on how things move.
Pretty much. They gave examples like setting up dynamic camera pans following a car's lines, or even transferring real-world driving motion onto a concept car video.
Like how a real car takes a corner.
Something like that. And they mentioned physics simulations starting to come in, making the motion more believable, obeying real-world rules.
Seems like creating and controlling dynamic visuals is getting way more accessible. Next up was universal inspiration generators. Sounds broad.
It refers to the idea that, everyday devices could capture all sorts of data, text, images, audio, And then software can perform multiple tasks across those different data types.
So your phone or tablet becomes an unexpected source of design ideas.
Potentially. Imagine sketching something rough, and AI instantly gives you detailed, realistic images based on it.
Cool.
Or recording city sounds, and AI generates music themes that could influence the interior design for an urban vehicle. It's early days, but the potential for novel workflows is there.
Let's talk geometry generation. Mesh versus BREP. What's the difference, and why do designers need both?
Okay, so mesh generation, like their Project Any example, creates models made of polygons. Think 3D scans, sketches turned into digital shapes. Great for quick ideas, early visualization.
Like scanning a clay model and getting a digital version quickly.
Exactly. Good for exploring form. BREP, or boundary representation, is different. AI is trained to generate precise models from scratch, understanding the math behind curves, surfaces, constraints.
Much more complex then.
Way more complex than images or text. It needs geometric accuracy. And they're even researching using this BREP understanding to automate things like assembling components together, their jointable research.
So mesh is more for early concepts, BREP for production-ready precision.
That's a good way to think about it. Mesh gets you a digital form fast for creativity. BREP gives you the engineering accuracy needed for manufacturing. They work together across the design process.
Personalization, big trend everywhere. How's AI helping there in auto design?
Bluewater restoration talked about reinforcement learning. The AI learns your preferences over time based on feedback, positive or negative.
So it adapts to the designer.
Yeah. Maybe it starts favoring certain aerodynamic shapes or sustainable materials because you keep picking them, or helps maintain a specific brand look across different projects. It learns your style, your goals.
Could make the process more tailored, more efficient.
Yeah.
Another concept was surrogate modeling. What's that?